Welcome back, Physics 30. This is the last Part B vector assignment. It's Part 7. And the objective here is to determine the resultant vector of two or more non-perpendicular vectors acting in two dimensions using the vector component method that we learned in the last assignment, breaking a vector down into its horizontal and vertical components. So what I'd like to do is to go over this sample football question with you. And then the rest of it is to be done on loose leaf and handed in as a hand-in assignment. There's a total of 4 questions. So determine the resultant of each of these. So here's one question, second question, third question, and then the last question is on the flip side there. So there's a total of 4 separate questions to do there after I go over this example with you. So the question reads, a football player is hoping to score a touchdown by running a complicated play. The end zone is straight north of him. He runs 5 meters at north 36 east, then changes his path to run 12 meters north 51 west. He meets a block and is forced to run 15 meters south 73 east before he's tackled. Determine the resultant vector and was it successful or not. Okay, so looking at those numbers, we're going to break each of these vectors down into a vertical and horizontal component, add all the horizontals, add all the verticals, and then we'll be able to figure out what our final resultant vector is for the question. Ideally, before we would have drawn a scale diagram for this, but now we're going to look at the vector component mathematical method. Okay, so the solution, once again, using the coordinate system here, anything going to the right is a positive x, anything going to the left is a negative x, any vector pointing downwards is a negative y, and pointing upwards is a positive y. So if we take a look at all of our movements there, these are just sketches of those vectors in the question. So for example, 5 meters, north 36 east, north east by 36, 5 meters. And then here's our other 2 remaining vectors. So we have 12 meters north 51 west, 12 meters north west by 51, and then our last vector, of course, 15 meters south 73 east. South east by 73, we get 15 meters. So those, a simple sketch, you don't have to even use a ruler. You can say I didn't use a ruler, just to give you a visual picture as to what each vector looks like. And you can see each vector is broken down into a vertical and a horizontal component. Also, what I've done here is with the red circles, I've used the coordinate system here to figure out if they're positive or negative. So this y is positive, positive. This x is negative because it's pointing to the left, positive. Negative y because it's pointing down, positive x. And then from there is just a matter of just what we did in the previous assignment, looking at our first vector there, break it down into a vertical and horizontal component. So if I'm looking for x, that's the opposite side, so I'm using the sine function there. So sine of 36 equals qx over 5. And of course, solving for that, we get 2.938 meters. And I didn't do any rounding off yet. And also I put a positive sign in front of it because it's a positive vector. Looking for qy, it's the adjacent side. So of course that's the cosine function, adjacent over 5. And that works out to be plus 4.045 meters. So we have to do that for each of the vectors. It's a little bit of work, but it's a mathematical method, and everyone should have the same answer when all is said and done. Looking at the second vector, again, the x is opposite the angle, the y is adjacent to the angle, so very similarly to find out qx, we're going to get that. Now I didn't work out the question here, I just simply wrote down the answer. You can write down the work and figure it out. And qi uses the cos theta, and I get positive 7.552 meters, so you can work through that and check it. And then the last vector there, maybe you could run through it right now, figure out qx and qy. Maybe pause the video right now and then come back and see what you get. Okay, if you had a chance to do that, QX, we're using the sine function again. It works out to be plus 14.345 meters. QI uses the cosine function. It's pointing straight down, negative 4.386 meters. Okay, so we've broken every vector down into vertical and horizontal movements. The next thing is to add up all the vertical movements, all the horizontal movements, using this. So this uses the sign sigma here just for notation, summing up or adding up all of the QX movements. So QX1, QX2, QX3. So basically all of these ones that I did over here, the 2.938, the negative 9.32, etc. So you can see I've just simply done that. Positive 2.938 combined with a negative 9.326 combined with a positive 14.345, and I get positive 7.957. So overall, after those three movements, we end up going 7.957 meters to the right. Okay? Then we do the same thing with the y's. So all of these ones that we figured out, the plus 4.05, and the next two, etc. So write them out, and we get plus 7.211 meters. And that's a y movement, and a positive y movement is straight up. So what we could do is sketch this. So we're moving to the right, then up, to the right, then up, and you can see what we have there. So notice I don't use the signs here. And if these had been negative, just simply write the number down. The positive and negative are just there to show you the direction to write the arrow. Because if you include a negative sign, then you use the tan function, you may not get the right answer. So once you know the sign, that tells you how to draw the arrow. And don't use the sign in the length of the side. So we can see 7.957 to the right, 7.21 meters up. So then it's easy to figure out the overall resultant vector, Pythagorean theorem as I illustrated over here. I can get rid of this, I think. And I can get rid of this. So a squared equals b squared plus c equals c squared, and then square root that. 10.97 meters I get for an answer here when I use the Pythagorean theorem. And then to figure out the angle, opposite over adjacent is tan, so 7.211 over 7.957. Then take the inverse tan, I get 42 degrees. East, north, east, 42 degrees north. So the overall movement looks like something like this. Okay, so that's how you do it. So it's a little bit of mathematical work here, but your answers will be good. There's little room for human error involved with this one when compared to drawing a scale diagram. Okay, so use this football example in doing the next 4 questions. So again, to recap here, you're going to do each of, now these are all separate questions here, they're not related to each other. So question A, question B, question C, then of course question 2 on the next side. Okay, good luck, see you later.